Welcome to Profiles in Quality, an interview program with the leading names in quality management. I'm Mike Richmond, publisher of Quality Digest and your host for this episode. All of us on the QD crew recently attended Hexagon 2012 Think Forward in Las Vegas. While there, we had the chance to see some terrific new technologies and talk with many thought leaders in manufacturing test and measurement. During the show, I sat down with Doug Duchardt, Vice President of Development at Hendrix MotorSports, one of the leading NASCAR teams in the world. Doug and I chatted about 3D metrology, the variance between design planning and production realities, and how the 2012 season is shaping up for the team. Doug, thanks for joining us here.
It's good to be here.
Great to have you on the show. Well, thanks for joining us again. And Hendrix MotorSports, of course, a well-known user of Hexagon metrology equipment, as well as a well-known race car manufacturer.
Right.
Tell us a little bit about Hendrix MotorSports and what the company's all about.
We're located in Charlotte, North Carolina. There's 550 employees. And our team, we run 4 NASCAR teams out of our facility. So our teams build and manufacture race cars for Casey Kane, Jeff Gordon, Jimmy Johnson, and Dale Earnhardt Jr. We also have an engine manufacturing company, so we make the race engines for those 4 cars, and then also for Tony Stewart and Ryan Newman's cars. So we make race engines for other competitors and our cars. We have, for each of those 4 cars, we have 14 race cars to get through the season. We race 36 races a year, so we need 14 race cars for each team. So that's 56 race cars in manufacturing flux somewhere in the process. Then we build about 700 race engines a year to campaign the season.
So how big is your facility?
It's multiple buildings. It's about 600,000 square feet under roof if you added everything up. So it's fairly large. For a race team.
For a race team. So tell us about Hexagon products that you use and how you use them to ensure the quality in your manufacturing process.
Really, when it started, when NASCAR changed to a new car, that they tightened up a lot of our tolerances on what they were looking for from us in chassis construction and body construction. And we saw that we needed to get something more accurate than our old tape measures. And so we started adding romer arms all through our process to check as we build the chassis, and then as we hang our bodies on the race car. So the chassis, when it's built, when we complete it, has to go to NASCAR to be inspected. They happen to use romer products too. So we got romer arms to start measuring the quality of our parts before we get them submitted to NASCAR, and that's how it started. And now it's gone through all the race car building and also preparation for the track.
And the state-of-the-art, of course, your state-of-the-art facility and state-of-the-art cars that you build, and of course you need that accuracy to ensure that you are at the cutting edge of the technology.
That's right. That's cutting edge of the technology and really cutting edge of the rules. NASCAR gives us tolerances, and we really have to take as close as we can to those tolerances to maximize our performance. So with the romer situation, as we build the race cars and then as we set up the race cars, in other words, as we put the suspension components on the car to prepare to go to the track, we will measure the key suspension areas of the car and import that into our simulation tools now, and that gives us a more accurate model of the car as we put it into the simulation program. So there's a lot of knock-on effects besides just manufacturing a car that helps us through our simulation tools all the way through the system.
What kind of tolerances are we talking about here? What kind of accuracies really are we dealing with?
The NASCAR tolerance for the bodies is 60 thousandths of an inch, and it's a 17-foot hand-built prototype. So for that, it's pretty tight. So there's a lot of work that goes in all through the process to make sure we're within those tolerances.
Now, I would imagine maybe this was more in the old days of this industry than it is maybe now, maybe because of the technology, but I would imagine that there's been some instances where you had some great ideas on the design, on the drafting board that you wanted to put into production that you couldn't for whatever reason. So tell me a little bit about how the technology, these measurement technologies that we're talking about here, help you avoid that situation where you can actually build what you want to design.
I think it's really, what it helps us with is understanding that NASCAR has a tolerance that we're not supposed to go over or we get in trouble. And sometimes we've gone over the line and we have gotten in trouble, but we try not to. And so it really allows us to put us right on the edge of where we want to go and have confidence that we're at the edge and not over the edge. Because if you didn't have that technology to do that, you couldn't go as far as you'd like to go, putting the body in a certain position or the chassis in a certain position. And so in that sense, it's helped us a lot.
So in other words, let me back up a little bit. So NASCAR has these limits that we can go to the edge of, and that's just to really maintain competitiveness and fairness across the
That's right.
industry. Right.
And so if we win a race, so we won last weekend, NASCAR takes that car, physically takes it into their possession and takes it back to their tech center and measures it. So that's how they make sure that we are within the rules and the tolerances. And that's why when we present the cars to NASCAR at the racetrack, we have to make sure that they're within their specs when we present it.
Now, have there been instances, not for you guys of course, but have there been instances where other manufacturers have actually had to give up a win that they had because their car wasn't within tolerance?
We've had, there's various times through our history that we've had situations at the racetrack that we've had been reprimanded for, and there are other teams that have had problems post-race, but they don't usually take the win away. They'll deduct points or fine you or suspend crew chiefs, but they don't. They don't take the win away.
And again, it's a season, so the point value, really deducting the points can be a big thing, right? I'm curious about R&D, and in this industry, R&D, of course, is such a fascinating thing. Talk to me a little bit about your research and development process. Talk to me about the stuff, and I'm not going to answer any secrets here, but the stuff that you have in development now. When do you think that's going to actually hit the tracks?
It's interesting. I have a background. I'd worked in the OEM area at General Motors as an engineer, and so you go through in production. There's a longer time from idea to production. We're in a constant state of evolution. So an idea this week can be on the car next week. So we have, and there are longer term things that we do too. So, but you can have ideas that are getting ready to be done and go on the car for our next race.
Okay.
So our iteration loops are very, very tight, and it can be week to week. Now, there's some stuff it could be longer lead time. It could be 4 to 6 weeks, but typically it doesn't get much further out than that.
And in terms of getting down to the nitty gritty of the development process of your machines, what is the real cutting edge? Is it drivetrain? Is it chassis? Aerodynamics? What really is the most cutting edge part of that?
Well, the things that matter the most in the race car are aerodynamics and then your engine. And so aero is something we're always looking at and developing, and so that drives a lot of specifications through our chassis and body side. And then from the engine side, we use more of the Brown and Sharp technology with CMM. So the parts that we make and the parts that we buy, we have to ensure with a precision 850 horsepower race engine, you have to make sure the parts you're putting in are top quality. Because if you have any engine incident, it can be catastrophic for points and potentially a championship. So there's a lot of emphasis on quality, obviously, in the engine shop, and we make a lot of our parts there. So it's a lot of work.
You cast your own parts in some cases?
We have to use General Motors castings for the block and cylinder heads and manifold by NASCAR rule, but we make a lot of reciprocating parts, so pistons, and then other parts within the engine, valve train parts, etc.
So now, is it like when you watch a race, you can, all the cars that are on the track at that time are all pretty much the exact same weight, pretty much all the exact same drivetrain? I mean, how much variance really is there?
Well, the drivetrain, the weight, there's a standard for the weight. The drivetrain is depending on your engine manufacturer and transmission manufacturer, et cetera. So we supply 7 teams with our engines, so 7 out of the 43 are our engines. Then there'll be, and we have Chevrolet, so there'll be Fords and there'll be Dodges and Toyotas with different power plants in them. So we'd like to think that we do what we can to differentiate versus our competitors. And we've worked hard with our drivers and their feedback to try to improve our power and performance and reliability, and I think we've done a pretty good job. We've won the last 6 championships, so that's been good.
That's great. Now you mentioned it before, you have an engineering background, and like many of our readers and our viewers out there, most people have engineering backgrounds who read our publication, and yet many of them also find themselves, like you do, dealing with a lot of the strategic initiatives and imperatives of their organizations. How does the kind of the two sides of the brain work together? They're kind of different disciplines.
Well, there are. It is, and it's kind of a diverse group that I manage because we have 50 degreed engineers on our staff. So they're generating ideas and thoughts on how to make the cars and engines better. And then we have a large component of the staff is manufacturing the cars. So the things that we try to look at, to your point, is the challenge is everyone has ideas and we have a finite resource. And that's where, for instance, the decision with the Hexagon metrology equipment was an important one because we had to say, it's a expense we have to believe in that we're going to get a payback on. And we believe strongly that we saw the capability of the equipment in our body construction, and we saw how we could take it to the next step as we prepare the cars for the racetrack, as we measure the cars when we assemble them, and that's when we made that decision. And so the decision for Hexagon metrology was no different than buying more wind tunnel time or buying more sensors for measuring in the race car. We had to take all that into account and sit down and say, yes, this is the right thing for the company to do, and that's what we do.
So the engineering really drives the strategy, ultimately, for an organization like yours.
And engineering combined with the crew chiefs. So the crew chiefs are the people at the track making decisions week to week in the fire, so to speak.
Sure.
And so they have a very strong feel on what will help them in the long run. And so when the engineering department sits down with the crew chiefs and we come up with ideas, we as a group come out with a decision and move forward.
Great. Now for the really important stuff. How's the season going?
Season's going well recently. We started off a little slow, led a lot of laps, couldn't quite get a win, and then sitting here in the beginning of June, we've won the last 4 races, so that's been a good deal, 4 in a row, and of course in this sport it can humble you very quickly, so
Sure.
we'll take that. We just won our 200th win as a company early in May at Darlington, and now we have 202 wins, so it's been a good past month, and hopefully it'll continue through 2012.
Great. Well, thanks, Doug. Thanks for
Mike.
joining us again.
Appreciate
That was Doug Duchardt. He's the Vice President of Development for Hendrix MotorSports. He's joining us here at Hexagon 2012 Think Forward. Doug, thanks again for joining us.
Thanks, Mike.
Three, two, one, fire!